Hi guys, good evening everyone. Good evening guys, how are you all? I hope everyone is doing well. So, yes, what we are going to do today is we are going to discuss about solubility product, which is a small topic of ionic equilibrium but yet very important. Whatever exam you write, whether it's a school exam or any competitive exam, you can surely expect one question from this small topic. So it's a very important topic, guys, and yes, we'll be studying about it within half an hour, and you will be able to solve most of the questions with the help of it. So yes, we will be starting with it, but before that, let me just quickly introduce myself to all the students who are new on the platform right now. So, guys, I am Manisha Rani, your chemistry educator at Unacademy, and I have enriched 5 years of experience at reputed institutes, and I have completed my masters from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, CSIR NET, and GATE. I have given best ranks through my students and am a plus verified tutor, guys. So, yes, this was about me, and I want everyone, those who are coming on in the classes and they are having a different name, so please introduce yourself also in the chat. Okay, so let's just start with the topic now. What is solubility product? So I hope you guys will be getting some information regarding solubility, right? Solubility and product. So solubility, if I say, is nothing but it is defined as the maximum amount of a solute that can be dissolved, right? In a particular amount of solvent at a particular temperature that we have learned, right? That we know the basic definition, but how we can define solubility product. So let's just quickly talk about its definition first, and then we'll be discussing other things. So it is defined as solubility product. We denote it as KSP, capital K, along with S and P is there in the, yeah, subscript. Okay, S and P is there to represent solubility product, right? So it is KSP. So how you can define it? It is defined as the product of. It is defined as the product of. Obviously, it's a product. So yeah, it is defined as the product of molar concentration of ions. Product of molar concentration of ions. Molar concentration of ions in a saturated solution of an electrolyte at a given temperature. Saturated solution of an electrolyte at a given temperature. Okay, and with each concentration term raised to the power equal to the number of ions produced, or number of ions produced on dissociation of 1 mole of electrolyte. Okay, how we can relate with it? Let's just take a general example of a salt, an electrolyte. Say you have an AXBY type of compound. Okay, so when you will do its dissociations, it's an electrolyte. When you're doing its dissociation, so what you will get XAY plus ions, plus you will get, yes, YBX minus ion. Now how we are getting this? You can relate with some example which will be like easily relatable. Like suppose if I'm giving you any salt like Mg2N3. Okay, Or suppose if I'm giving you here magnesium chloride, simple salt. Okay, so if I give you magnesium chloride, so magnesium chloride, how you will get the charge? Magnesium, because it's one only, so magnesium you will get one only. But there are two chlorine, so the Y is 2, so you will get here 2 positive charge, that only, right? Then the Y is 2, so you will get 2 Cl, correct? But on the magnesium there is 1, so you will get minus. So like that you can easily relate any electrolyte how it will dissociate. Okay, so what we can understand, that suppose if I have an electrolyte AXBY, it will dissociate into what ions? It will dissociate as A, yes, XAY plus, like we can write it little properly, XAY plus plus what you will do? Yes, YBX minus. Okay, okay, very good. So applying, what you will do if you apply the law of what? Mass action. So what you can write? Can you write the equilibrium constant over here for this electrolyte? We can write, yes, by applying law of mass action. So it says that the equilibrium constant for this reaction, we can write what? The concentration of products raised to the power, how many ions are produced, correct? So Bx minus will be there, raised to the power Y, okay, because Y is the number of ions produced over here, which you can relate, divided by, guys, what you will be having? The concentration of reactant. So there is no, yes, number for it, so we can just mention that. So K is equal to AY plus X and this. Now if, because for the salt concentration is going to be fixed, so if I multiply K into AXBY concentration, which will be A Y plus X B X minus Y. So this all together I can consider as KSP. So KSP will be equal to A Y plus X and B X minus Y. So basically whatever ions it dissociates, how you can write KSP? The number of ions it dissociates. Like let's just go to the definition and you will be able to relate better. Yes, let's just go to the definition, guys. You will be able to relate very much better. So we got in this manner. So what it said that it is defined as product of molar concentration of ions in a saturated electrolyte at a given temperature, with each concentration term raised to the power equal to number of ions produced on dissociation of one. Dissociation of what? 1 mole of electrolyte. So that's what you can understand. It's very simple. Okay, so for any salt, if they given, you can find it out. Can we write its KSP? What say? Let's just relate with few examples. Suppose you have AgCl. So AgCl will give what ions, guys? Ag plus Cl minus ion it will give. So what will be the KSP? KSP will be just Ag plus and Cl minus. Right? Very good. Now, if suppose we have to write like another one, let's just discuss. Suppose you have PbCl2. One example, two example. So PbCl2 will dissociate as Pb2 plus 2Cl minus, yes or no? So how will write its KSP? Pb2 plus ion into Cl minus ion concentration raised to the power 2. Correct, guys? Very good. Like suppose if I give you another, say you have FeOH3, how it will dissociate? Yes, it will dissociate as Fe3 plus ion plus 3OH minus ion. So KSP will be what? Yes, guys, Fe3 plus ion concentration into OH minus ion concentration raised to the power 3. Very good. So this way you all can relate. Now we have to understand one more term, that is how we can, yes, do the expression of solubility product in terms of solubility. So expression of solubility product in terms of solubility, let's just understand. So what we can relate? Expression of solubility product in terms of solubility. In terms of solubility. How you can get that? So guys, first of that, we have we can talk about 5 cases. In general, we can find out 5 types of salt. So case 1, when you have a AB type of salt. AB type of salt, if you have, it means you have 1:1 ratio, A and B, and like example, you can consider AgBr. So AgBr will dissociate into ions. Yes. How? Ag plus and Br minus. Correct. Ag plus and Br minus. Now what you can relate, because they are in 1:1 ratio. So obviously if the one ion solubility is S, even other ion solubility is also going to be S. Yes or no? So if I write KSP, it will be Ag plus ion concentration into Br minus ion concentration, and if I mention their solubility S into S, so that will be equal to S square. So solubility in terms of like KSP in terms of solubility will be find out here. KSP is equal to S square for this type of case. Clear with it? Yes or no, guys? Like suppose if I say the second example, case 2. Yes, case 2, what you have is, you have which type of salt, guys? Say you have AB2 type of salt. So case 2, you have AB2 type of salt. So it means you have A and B, cation and anion in 1:2 ratio. Okay, so what will happen? Example I can relate. What is that? Yes, I can relate that. You have PbCl2, we took before also, right? PbI2 you can take. So suppose PbCl2 I have, it will dissociate into ions Pb2 plus and 2Cl minus. So because they are in 1:2 ratio, so if the solubility of lead is S, this will be 2S. Correct. What is the KSP? We'll write Pb2 plus ion concentration into Cl minus ion concentration to the power 2. So Pb2 plus I consider as S, Cl minus as S, and to the power 2. So what I will get? Yes, it is 2S. Cl minus is 2S concentration that we related with the solubility. So what I'm going to relate, it is going to be 2S. Yes, 2S to the power 2. So what will happen? 4S square into S. So you will get 4S cube. So here in this case you will have KSP is equal to 4S cube. I hope everyone clear. It's simple. Yes, case 3 if I talk about, what we have is, say we have A to B type of salt. That also can exist. No, it's same only. Means your cation is 2:1 ratio. Example of this, say you have H2S. H2S. So H2S, how it will dissociate into ions? 2H plus ions plus 1S2 minus ion. Okay. So if H plus ion solubility, if I relate, it should be 2S, while sulfur has to be S, because they are in 1:2 ratio, right? If sulfur is 1, there are 2 hydrogens. The solubility of sulfur is S, so hydrogen will be 2S. If I write KSP, it will be H plus ion concentration to the power 2 and sulfide concentration. H plus ion solubility is 2S. So 2S to the power 2 into S. So it will be again 4S cube. So whether it is A to B or AB2 salt, the KSP expression is equal to 4S cube. Okay guys, very good. Next case, case 4. What you can understand here, what type of salt we see in the case 4? You have AB3 type of salt. What you have is AB3 type of salt. So if I take AB3 or A3B, I will have same expression. I can relate with that. So 1:3 ratio. Okay. Example of this, what I can relate? Yes, tell me guys. Example of this, what I can relate is, I can relate as, say, gold hydroxide or silver hydroxide. That's what we can understand. So what we can relate, or you can relate with lead hydroxide only. We have learned that, right? So example, lead hydroxide, what will be the, guess what will be the ions when it will dissociate? Pb3 plus 3OH minus ion. So if its solubility is S, it will be 3S. KSP if I write, what it will be? Pb3 plus ion concentration into, yes, OH minus ion concentration to the power 3. So this will be considered as S into 3S to the power cube. So 3S cube will be 27S cube into S. So it will be 27S4 will be the KSP relation here. I hope everyone understanding. Anyone having any doubt, let me know, guys. Yes. Let's just discuss case 5. So case 5 also, if I say you have A3B, 1 is to B, 3 is to 1, you will have the same expression. KSP will be equal to 27S4. No need to mention. Same way only you will be doing it. Now, let's just relate the case 6. What is that? If you have A to B3 type of salt, what you have is A to B3 type of salt. Okay, like let's just discuss case 6, A to B3 type of salt. So A to B3 type of salt, what I can understand, they are in the 2:3 ratio. Okay, if they are in the 2:3 ratio, what I can relate that example, say AS2, S3 I'm giving. So if it will dissociate, what ions it is going to give? 2As, 3 positive ion, yes or no? And along with that, what it will give? Plus 3S2 minus ion. Correct? Now if I write its concentration, so solubility will be 2S and here it will be 3S. Correct? So KSP, if you write, it will be AS3 positive to the power 2 and S2 minus to the power 3. So it will be very simple, 2S to the power 2 and 3S to the power 3. So 2S to the power 2 is 4S2 into 3S to the power 3 is 27. So 27 into 4, you will get 108 S5. So in this case, KSP will be equal to 108 S to the power 5. Okay. Very good. So what we can understand over here, guys, it's very simple. You can find it out anytime. The expression in terms of solubility. Suppose in the question they have already given you solubility and they're asking you to calculate KSP. So you can just take in the same whatever salt is given accordingly. You can use that and find it out. Okay. Now, if I say one more thing, that example, let's just discuss the example. So I have a question. Write the solubility product of or solubility expression for what? Zirconium phosphate. Zirconium phosphate. Zr3PO4 4. So you have to tell that. What you will do, whatever you have, first you will write the salt, zirconium phosphate. So you will see that what you will be getting the ion. So you will get Zn, Zr, 4 positive, but you will get 3, correct? Plus you will get what? You will get 4 PO4 3 minus. Correct? If you will remember that AXBY, so whatever salt they'll be giving you, it will be so easy for you to tell the ions, right? That dissociation, if you will remember. Very good. How I did 3 zirconium, there's 3Z, but there are 4 PO4, so 4 plus here. 4 PO4 because PO4 are 4, but because there are 3 zirconium, so 3 minus. So it's so simple to write the ions by learning that general way. Okay. Now what we'll be doing? Yes, if the solubility of this is 3S, this will be 4S. KSP expression will be what? Tell me. Zirconium 4 plus to the power 3, concentration PO4 3 minus to the power 4. So if this is 3S to the power cube, this will be 4S to the power 4. So 3S to the power cube, it will be 27S cube into 4S to the power 4 will be 4 4s are 16, 16 4s are 64, 64 4s are, yes, what it will be? 64 4s are 256, if I'm not wrong. What say, guys? Yeah. So if you have 4 into 4 into 4 into 4, you will have 256. I hope everyone is able to relate. So it's so simple. You will have 256 but s to the power 4. So when you will multiply 256 into 3, what you will get? 27. You will get what? 6912. But you have base same, s4 plus s3, you will get s7. So what you got? You got KSP is equal to, yeah, 6912 s to the power 7. So if you want to write the solubility expression, what you can do? KSP divided by 6912. If 7 here, if you will take this side, it will be 1 by 7. Everyone clear? This was a very important question related to solubility product. What we did, we have written the solubility expression for zirconium phosphate. So whatever salt they give, first you write its ion. How you can write it? I have told you a short way, a shortcut. Always remember this, that any salt, it's going to dissociate this way. XaY plus plus YBX minus. So accordingly you can get the charge simply. Okay, and then if you get this, you can easily get the solubility expression. Everyone clear? Yes. Anyone having any doubt? So question I'm giving everyone, write the solubility expression. Write the solubility expression for Sb2S3 antimony sulfide. Okay, so you have to tell me what will be the correct option for it. So it is what type, guys? I hope you are able to relate. It is A2B3 type of salt. Correct? What it is? It is A2B3 type of salt. So you have to tell me what will be the expression. A 27 s to the power 4, B 108 s to the power 5, C 4s cube, D 2197 s to the power 5. So everyone has to tell me what will be the correct answer in the chat. I'm giving you 60 seconds, guys. Everyone has to tell. It's really, really important. Everyone should know about it, guys. It's so important topic. Yes. Okay, very good. Good, guys. Rest of the people also should answer it. So it will be very simple. It will be 108 s to the power 5. Very good, everyone. Because it is A2B3 type of salt. So you can relate that. Simple. Now, there are many applications of solubility product. But one of the application of solubility product is it helps to, yes, predict the formation of precipitate. The formation of precipitate. What? KSP helps to predict the formation of precipitate. Precipitate. How you can relate that? So all of you know that at equilibrium we write KSP, but other than equilibrium, for any salt at any other condition, if you will write, that will be your ionic product. So it's very simple. If your ionic product, yes, if it is less than the solubility product, so what you can relate? There will be no precipitation. Yes, if ionic product value is greater than KSP, there will be precipitation. And third one, yes, if ionic product is equal to KSP, there will be no precipitation. Clear with it, guys? So ionic product is the product of concentration of ions at any condition other than equilibrium. Correct? Like we write reaction quotient, no? Same way, reaction quotient like we write other than equilibrium, when you write the equilibrium constant, like the constant of reaction, so that you consider. Same way, ionic product, not at equilibrium. When you are finding out at any other condition, you will consider. So you can compare that value and get to know whether the precipitation will be formed or not, okay, in the solution. So tell me, guys, if there will be a no precipitation, it means it's a unsaturated solution. No precipitation means it's unsaturated solution. If there will be a precipitation, what you will say? It is saturated solution because it has started settling down. So it means what? It is undergoing precipitation, means it's a super saturated solution, guys. And if there is no precipitation, it means it is saturated solution here when you have both are equal. Very good, guys. So I hope everyone understood about solubility product. We understood what is solubility product, how we can express it, how we can express solubility product in terms of solubility, right? How we can get that expression, how we can solve the questions related to it, and also one of the major application that it helps to predict the formation of precipitate. So here, guys, on YouTube we discuss the topics, but obviously we're not going in detail, right? So if you want to understand every topic in detail, you can join even our classes which are going on in our Unacademy platform, guys. So on our Unacademy platform, we have a absolutely free classes also, like that are our special classes, which every day chemistry class is there, either for 11th or 12th, it is 6:30 to 7:30 p.m. So you can check that, right? Monday, Wednesday, Friday it is for 11th standard, and Tuesday, Thursday, Saturday it's for 12th standard. So it's a special class, right? And what you can relate, everyone, that these special classes, yes, can benefit you a lot. It's a 1 hour session, and you can also let me know in the comment section if you want any specific topic for me to discuss in the next upcoming YouTube classes, so that I can schedule a class on that topic and we will be discussing it very soon. Okay, and when you are solving a questions related to this topic and you feel any doubt, you can also post that in the comment section so that we can discuss it together. Okay, guys, you can anytime enroll for our plus course classes as well, and for that you can use my code MRIS10. In that we do the complete comprehensive coverage of syllabus. Okay, so yes, I hope all of you understood the topic, and that we discussed related to ionic equilibrium, that is your solubility product. You can check some other videos also which is there related to ionic equilibrium to understand the topic in a short and crisp manner. Okay, so okay, guys, I hope you enjoyed the session, and we'll be meeting in the next session then. Thank you all of you. Bye bye. And if you like this session, make sure, yes, you are subscribing this channel, and as well as, yes, you are pressing the bell icon so that you will get all the information regarding upcoming classes and you will be updated. So okay, guys, we'll be meeting in the next session then. Thank you all of you. Bye bye. Thank you, guys. Bye.